We are finishing the very last section of official notes. And so what we've been talking about is human population growth. The idea that the human population has grown exponentially. We haven't reached carrying capacity. And one of the problems is that all of our pollution problems really relate back to the fact that we just have too many humans. Too many humans producing too much waste. And so all of these environmental problems really go back to that. And so we talked about some solutions: zero population growth, conservation, sustainability. And now we want to look at some of the specific problems that we need to turn our attention to. One of them is going to be global warming. Now, where it says global warming, I'd like for you to go ahead and underline that, but write climate change. The word climate talks about long-term weather patterns. And so when we look at the climate of the Earth is constantly changing all the time anyway. But what we've seen is unnatural changes in the climate of Earth. And here's where we have to look at something called greenhouse gases. Greenhouse gases are things like carbon dioxide and methane. And so these gases trap heat. Greenhouse gases trap heat, period. That is a scientific fact, that if you fill an area with greenhouse gases, those greenhouse gases trap heat. In fact, that's actually what makes Earth just the right temperature. Remember Goldilocks? And the porridge was too hot, and this porridge was too cold, and this porridge is just right. Turns out that Earth's temperature is just right to support life. And we need those greenhouse gases to trap some heat. The problem is excessive greenhouse gases. Too many greenhouse gases lead to an abnormal increase in the Earth's surface temperature. Extra CO2 comes from burning fossil fuels. And what we can't deny is that humans cause this. We cause excess burning of fossil fuels. If you look back even 200 years ago, humans weren't even really burning that many fossil fuels. But the changes in technology, now we burn so many fossil fuels and we release excessive carbon dioxide. CH4 actually comes from landfills and from cows. It seems like, well, how can cows be bad for the environment? It used to be, again, that we didn't eat as much meat as we do today. And so having a tremendous amount of farms that grow cows result in excess greenhouse gases. So these excess greenhouse gases trap heat. And extra trapped heat will actually change the temperature and the climate pattern. The effect is like Earth has had a fever. Now, it's not the same as what you see in a lot of movies where all of a sudden there's a dramatic weather event. But we do see an increase in temperature, 2 to 4 degrees Celsius. We see weather patterns that are changing, polar ice caps may melt, flooding coastal cities and contaminating drinking water with salt water. And so we do see this idea of climate change. Now, some people will say, well, it was a really cold winter, so that means global warming isn't true. If you look at the overall weather patterns of Earth over a year, that's where we see the increase in temperature. Some places will still be cold, and some places will be really cold one winter. But if we look at the overall average, we see an increase in the temperature. And so the effect of global warming is really the melting of the polar ice caps, the flooding of coastal cities. Oh, it's frozen, that's fine. Now I'm going to have to go back. If we look, we actually have another problem that ozone depletion. And ozone depletion has nothing to do with global warming. They are two very different problems. Ozone depletion is literally the depletion of the ozone. So let's talk for a second about what the ozone is supposed to do. The ozone is O3, not oxygen, but O3. And O3 is supposed to absorb UV rays. So coming from the sun is a tremendous amount of energy, light energy, heat energy, and what's called UV or ultraviolet radiation or energy. And normally what happens is that when that energy comes from the sun, the ozone will actually absorb some of that energy and protect Earth. However, ozone depletion, deplete means to decrease. So global warming, remember, is where the Earth increases in temperature. Ozone depletion is where we lose ozone. And ozone is supposed to absorb UV rays. So there's a chemical called CFCs, and you do need to know that name, CFCs, chlorofluorocarbons. You don't have to know that part, just CFCs. CFCs were once in refrigerants and aerosol cans, and they destroy ozone molecules, creating a thin ozone layer or even a hole. And so these CFCs were in refrigerants, they were in aerosol cans, and for the most part, a lot of developed nations have stopped using them, but some nations still continue to use CFCs. And so what we see is that the ozone molecules are being destroyed, and the problem is that CFCs can destroy many ozone molecules over many years. It's not like it just destroys one, it's kind of like pinball, where it keeps bouncing and breaking, or the game Brick Breaker, where the ball keeps breaking all the bricks. That's what CFCs do. So once they're in the atmosphere, it's really hard to get rid of them. So we have ozone depletion, and so ozone depletion results in extra UV radiation. Now UV radiation is not heat, it's a different type of energy. Harmful UV radiation reaches Earth, causing increased numbers of sunburn, skin cancer, cataracts, which are damage in the eye, and crop damage. And so what's supposed to happen is that the ozone should be protecting us from those UV rays. And the chlorofluorocarbons destroy the ozone, meaning more UV rays reach Earth. So that's two problems so far, global warming and ozone depletion. Next we have what's called acid rain. Acid rain is caused when emissions from cars, like sulfur and nitrous oxide, react with oxygen and water. And so what we will sometimes say is that acid rain knocks your socks off. Acid rain knocks your socks off. Nitrous oxide and sulfur oxide is what causes acid rain. When the car emissions, and what's hard is that when we watch a car now, we don't see a lot of the emissions that come out of the tailpipe. Most cars still release a lot of pollution. It's just not pollution we can still see with our eyes anymore. So these emissions, the sulfur and nitrous oxide, get into the air, and then the water that's in the air, the water vapor in the clouds, when it falls as rain, it becomes acid rain. Now reminder, acid means that it's below the pH of 7. Remember, 7 is neutral, above 7 is a base, below 7 is acid. And so the problem with acid rain is that it can actually disrupt aquatic ecosystems. That's the biggest problem. If it rains and it were acid rain, we could just go inside, but fish don't have anywhere to go. And then that acid rain just sits there in the aquatic ecosystem. It makes soil less fertile, meaning we can't grow as many plants, and it can damage human property. So when you look at how they've had to re-clean the Statue of Liberty, that's partly because of acid rain. Then we see water quality problems, and a lot of people think that most pollution is just throwing trash out the window. But what we have to realize is that a lot of times the trash that's on the ground when it rains gets washed into ponds and rivers and lakes and streams and oceans. Have you heard about the huge garbage area in the Pacific Ocean that is about the size of Texas? And it's just all this garbage. And that's because pollution that happens on land often ends up in the water. We've also talked a little bit about fertilizers from land and this idea of if you put fertilizers or pesticides on your grass, again, when it rains, it gets washed off by runoff into the water, and that then pollutes the water. And then one of the last ones that we're going to talk about is habitat destruction. And we want to put a really big star by habitat destruction because it is considered the #1 cause of extinctions. When we look at endangered species and extinct species, endangered species are at risk of becoming extinct. Extinction refers to the loss of a whole species. So when we look at human impact, a lot of times we think of, oh, don't hunt the polar bear. That would put the polar bear in danger. A lot of times it's not hunting that has put the animals or plants in danger. It's habitat destruction, destroying their habitat. So while it is illegal to shoot a bald eagle, it's not illegal to cut down trees. And that's where the bald eagles need to live and have their nests and raise their young. So habitat destruction is really the #1 cause for what we call biodiversity loss. Biodiversity, we know bio means life. Diversity means different. So biodiversity looks at all the different types of life that we have. And so this habitat destruction, deforestation, draining and filling wetlands, all of those are going to mean that we're going to lose a lot of different types of living things. Now, these are two really important pollution examples, bioaccumulation and biomagnification. These both have to do with chemicals, like pesticides or herbicides, chemicals that damage living things. Bioaccumulation is where you collect in the body, in the environment. So let's say that we sprayed some pesticide on a lawn to kill like the ants, and then the rain came, washed the pesticide into the lake. Any animal that's in the lake right then will accumulate or collect those chemicals either on or inside of its body. And so bioaccumulation is just where you collect it in your body. However, as organisms start to eat, biomagnification is the 100% transfer of chemicals in the food chain. Remember when we talked about food chains, you transfer 10% of the energy? When you eat an organism that has pesticides or herbicides on it, you get 100% of any chemicals that were on their body. And so biomagnification is a much bigger problem in our top consumers. So it's greatest in organisms like our top predators, because here we have our producers, and the zooplankton eat the producers, and they get all their chemicals. The small fish eat the zooplankton, the large fish eat the small fish. Our fish-eating birds are collecting all of these chemicals that got accumulated and magnified up the food chain. That's the end of the notes. So if you'll please make sure that you fill out your summary box, that'll be all.